Alright guys, this goes with task sheet 712. Again, we have another rough running misfire type scenario, so this one's going to be a little bit different, but we'll walk through it. So we'll start here by going to the misfire monitor and trying to isolate what cylinders we have a misfire on. So here we go, we'll get started. So we've got our misfire monitor up here. I don't know how well you can see this, but the vehicle's running a whole lot worse than it was before. Now, we've got misfires counting on 1 and 5. Now, I said before that you kind of have to look out for those, what I call like a sympathetic misfire. These things are counting up exactly the same. So looking at this data, it looks like we actually have 2 cylinders that aren't firing right now. And that makes sense because this thing is running, like I said, a whole lot worse than it was last time. It's shaking pretty bad. And I smell some fuel, so that's another indicator that you've got just a dead miss somewhere. So we're going to shut this thing down and run through a couple more of our tests and see what we can't figure out. So as you guys can see, we don't have any spark coming out of our spark test here. I'm actually hooked to cylinder 3. It wasn't counting on the misfire counter, but it's not firing either. I tried to hook it up to number 1 and ended up breaking another one of my spark plug wires, so unfortunately I can't afford to keep replacing parts on this thing. So what is actually happening is this whole bank isn't running. So none of these coils are firing at all. It's only running off of one bank of this engine. So now that we know that, we can fine-tune our testing a little bit and see if we can't track down what caused the problem and what caused this whole bank to shut down. So we'll show you guys a wiring diagram and then we'll continue on with our testing. Alright, so this is our wiring diagram. I drew this out, just copied it straight out of AllData. Figured this might be a little bit easier for everybody to see. So we know that we're missing a whole bank. So when you look up the wiring diagrams, you'll realize that we have an odd side and an even side. We've got 1, 3, 5, and 7, and then our other bank of coils runs on a completely separate circuit. So we're divided side to side. So that can kind of help out with our diagnosis a little bit. So we know none of these are firing. So if we knew, say if we had just number 1 that wasn't firing the coil, then I'd be going probably after this connector right here. We'd be looking for power from our fuse and everything from our PCM. So all our testing would be localized probably right around here. But since we're missing the whole bank, we're going to look for things that are in common between all of them. So you can see each one of these coils has its own separate ignition control. So we've got 4 of them. We've got this one here, this green wire, our red wire, and our blue wire. So all of those are only affecting individual coils, so that we know it's probably not going to be, all 4 of these have an issue. I mean, I suppose you could have a PCM issue going on, but typically you'd have more issues than just, losing one bank. It's possible, but not real likely. So again, we're looking for things that are in common. So low reference, that's going to be kind of a feedback to the PCM. I doubt losing that would kill all this, but we could take a look at this low reference. Maybe we'd take a meter and ohm out from these wires up to the PCM to make sure that there's continuity. But typically when we lose everything, we're going to start with the basics. We need power and ground. So we've got a 15 amp fuse up here that feeds all of these coils, so we're going to check that fuse and then make sure that power is getting down to all of our coils. And then you can see now down on the bottom is the ground side. So all these coils share a ground. They come to a splice, they go through a connector, another splice, and then to ground. So that's probably where I would start, and that's where we're going to start. Typically when I do this kind of stuff, I start at the top of a diagram and work my way down. So we're going to check out that fuse and see if we've got power going out to our coils, and then we'll go from there. Alright, so we're under the hood. I've got my test light here. We're going to check this fuse real quick. My test light is a little LED powered one. It's a snap-on. This thing's pretty cool. It's got a little screen in it, so when you hook this up to power, not only does it light up like a normal test light, it actually gives you a little voltage reading on the screen. So it's pretty cool. It's pretty handy to have. So our 15 amp injector A fuse, we're going to test this out real quick. We've got the key on already. So we've got power, got 12.7 volts. We got power and 12.7 volts, so we know our fuse is good. So the next thing we want to do is look at our diagram and see where this power goes to. Just because you have a good fuse doesn't mean your power is actually getting to your component. So I know that there's a couple of connectors and some splices in this line, so there's opportunity for some other issues between here and there. So we're going to go to the coil and make sure we've got power at our coils. So I've got all the connectors undone at all of my coils down this bank. It's the first pin in each one of these connectors is going to be our power, our ignition out of this fuse. So I'm going to come to the first one. I'm going to check all of them. So we've got 12.7 on that one. Same on that one. 12.7. 12.7 and 12.7. So our fuse is good, and it's actually making it down to all the way down to down to our coils. Like I said, we've got some splices, and there's a connector right here in the middle of all these coils. So we know that we're good through the harness, through the splices, through the connector, and out to each one of these coils. So we're good on the power side. Alright, we've got our meter set up. We're about to test our ground side of the circuit. Something to keep in mind when you are testing the ground side of a circuit, if you're checking continuity with your meter, everything needs to be off. Your ignition needs to be off, and it's also a good idea to unplug your scan tool if you have one plugged in. If you have the ignition on, you can get some kind of screwy ground readings out of these things. So if you're ever testing something and you get just some real weird looking ground numbers on your or resistance readings on your grounds, check to make sure your key's off. And the reason why I mentioned the scan tool is because having that hooked up, even if the key is off, can sometimes keep your PCM awake. And if your PCM is awake, it can kind of screw with your ground readings. So I kind of had that happen here for a minute ago. So I turned my key off and let everything power down, and all my ground stuff kind of returned to normal. So I've got my my little test probe already in the ground here on the first connector. So I'm going to go ahead and check to ground. I'm not showing any continuity to ground on my ground circuit. And this is something I failed to do when I had my test light out, but when you get something like this, first thing you want to do with a test light is test your test light. And I didn't do that, but obviously when we hit that fuse, it lit up, so we knew we're okay. But if I hit that fuse and nothing happened, that would be probably the first thing I'd do, is double check my test light. But we've got no continuity on our ground circuit here, so just to double check that I'm hooked up right, you know, I've got one clipped to my negative battery. We're going to come over here to our alternator and make sure that we actually are hooked up right. So if we go to the body of the alternator, we've got less than an ohm going back to the battery, so we know we're hooked up right. So we're missing a ground on this here, this connector for our coil. So I'm going to go down and test this next one. Actually skip down to 5. Nothing there also. So I'm not going to do all of them. We know we had power on all of them before. We're not going to have ground on any of them this time with the whole bank being dead. One other nice thing about these little test probes is that you can use them for doing what we call pin drag. So these terminals over time can kind of lose their tension. So you use these test probes And when you test one of these, you want to feel a little bit of drag on them. So these are good for testing that also. If you were to put this into one of these terminals and there was no resistance in there at all, and you could flip that connector over and this thing just fall out the bottom, you know you probably got a terminal issue there. But all of our terminals check okay. So next thing we're going to do, we're going to refer to our schematic, and there's a connector in the ground side. So that connector happens to be this one right here. So while we're right here, we're just going to test and see if we have any ground coming out of this connector. So we're going to look for the black wire, which is this one right here. So we're going to test, put our test probe in there, and still no ground. So we know we're missing a ground. We're missing a ground for this entire bank. That's why none of these coils are firing. So the next thing we would do is trace out this wire from this connector down to our PCM. And we may have to dig through some of this wiring to try and find it. There's another thing that may be an option depending on how you want to do things, but I would run it by, you know, a service advisor, maybe even the customer. If you know you're missing a ground and this is the only ground that you're missing, it may just be a rubbed wire or something. It may be a whole lot faster just to run a new ground wire to this whole circuit. So I've done that in the past. Instead of having to tear through all these harnesses and find one little bad spot in them, you just make your own ground and just bypass the old one. So it is a possibility, but like I said, if you're going to do something like that, I'd make sure everybody kind of signs off on it. But so that's what we found for this one, is a bad ground on this circuit. Killed all our coils. So if we can get those task sheets filled out the best you can, that'll wrap us up for today. Thanks.